In this chapter, we want to look at polynomial functions. So a polynomial function in general is going to be a smooth, continuous function where your highest exponent is going to be greater than 1. We call this highest exponent the degree of the function. So say the highest exponent was 7, we would say it's the 7th degree polynomial. Now sometimes when you look at the lower degrees, they have a more specific name. So say you have x cubed. 3 is the highest exponent. We would call that the cube or cubic function. Okay, but as you get a little bit higher in your exponents, they stop kind of having specific names. So some you might be familiar with. X squared is quadratic, x cubed is cubic, x fourth is quartic. And then after that, they kind of go away and we just call it the nth degree or the 12th degree, the 20th degree, those types of things. Okay, so you get the name by that highest degree. Now, that highest degree helps us describe the polynomial, okay? So when we describe a polynomial, I'm going to look at describing it from an equation and from a graph. When I look at an equation, there's actually two forms of the equation. There's what we call the standard form of the equation, and then there's a factored form of the equation. Either way, the equation will always have what we call the leading coefficient. Okay, the leading coefficient comes from the highest exponent, the number in front. So leading, it's going to lead the function because it's the highest exponent. Okay, so that's where we get the leading. It's because it's attached to the highest exponent. Okay, so the first thing that I would do is I'm going to look for the highest exponent and notice, okay, that must lead the equation. Whether it's in the front or not, that's why it would be leading. Then we also call it the leading coefficient. Coefficient means the number in front. So the idea of that the leading coefficient test comes from, I'm going to look at the highest exponent and the number in front of that highest exponent. So I'm going to look at two values. That's why we look over here. We call it ax to the n. So I would look at the a as the coefficient and the n as the highest exponent. Okay? So when doing this, I can come up with different ways to describe the polynomial. Okay, so just these two values are going to tell me a couple things. The first thing it's going to give me is, of course, the name. Remember, we talked about the degree of the polynomial, which is just the name of the function, comes from that highest exponent. Okay. Another thing that this n can help us know is it can tell us how many possible rational solutions there would be. Now, remember when we talked about quadratics, we looked at the word solution meaning a couple different things. So solution, remember, can mean 0, root, x-intercept. All of those things mean the same thing. Okay, so one thing that we can tell is the name. Another thing we can tell is how many possible solutions, all from just that highest exponent. Now, I say possible solutions because we're going to have to verify. We're going to take these numbers and we're going to check them. We're going to check to see which one actually works to be a solution. Okay? And we'll look at that later on. The next thing that it can tell us is the number of possible turning points. So we call them now a turning point from what we used to call them a max or a min, an extreme. So for example, if I draw any polynomial, let's just draw one here. Remember, smooth and continuous, so it would go off to infinity. A turning point is described by what we used to say is a max and min. The reason we call them turning points is because at this point, we don't want to classify, oh, there's two minimums and one maximum. We don't want to know that. We just want to know how many times will it turn and change directions from increase to decrease or decrease to increase. So that's what we call our possible turning points. Okay. Remember, another way to call it as an extreme of the graph. we could classify it as maximums and minimums. I'm going to find that by taking n and subtracting 1. So it's not just the exact number of the highest exponent. I need to take 1 away. The reason we're going to take 1 away is because it takes 2 directions to create 1 turning point. So that's why we're going to subtract 1 from it. Okay. Now, everything so far that we've looked at involves just the n, that highest exponent. So now we need to look at, well, what are we going to do with this a, this coefficient? We haven't talked about it yet. We're going to find what we call our end behavior. So end behavior is literally just what do the ends of the graph do? Okay, so we're talking about the arrows. What are the arrows, the end behavior doing? Okay, so I kind of think about that as the arrows. Okay, that's why also I've kind of in here, I've given you what the arrows will look like. Okay, so remember we're going to look at two things. We're going to look at the A and we're going to look at the N. So when we put the A and the N together, let me get rid of that here. When we put the A and the N together, I can kind of create 4 different scenarios. Okay, so let's say that we first want to look at A. Well, A can be either positive or A can be negative. Okay. Then we could have an exponent. Remember, the exponent has to be greater than 1. So therefore, I can't have a positive and negative. That doesn't make sense. So instead, I could have the N being even and the N being odd. Okay, so N can be even and N can be odd. So that's going to create our 4 scenarios because A being positive and even, one scenario here. A being positive and N being odd is another scenario. Okay. N being negative and A being negative and N being even, that's another scenario. And A being negative and N being odd is our last scenario. So we create 4 scenarios, which we've stated here. Okay, and that's what we're looking at. So all we want to do is look at what are the ends going to do. The easiest thing to do is think about, well, what do you already know about an even number? The first even number that I just pops in my head is the number 2. Okay, so we already know about a quadratic, right? Say that x were squared. Okay, first off, that's going to be n being even. So that's going to be this scenario and this scenario. Those number 1 and number 3 there. Okay, so, well, over here in my example, not, yeah, over here, what I've written. So if we have x being squared, so let's think about that. Think about what a quadratic could look like. Well, a quadratic could open up or a quadratic could open down. Okay, so what do I notice? Well, anytime that we have an even function, my ends are going to either open up or they're going to open down. So the easiest way that I can think about this is by literally looking at the word even, and it kind of helps me know what the ends are going to do. So if I have something that's even, I know that I'm either going to be both up, both of my ends are going to be up, or I'm going to have both ends be down. So I could either be up, or down. We could call that rising to the left and right, or falling to the left and right. Okay. Even's going to be exactly the same. Now, if we think about odd, okay, so the first odd number that I think about is just x to the first power. Now, that's not a polynomial, but I can still come up with an idea of what that's going to look like. So let's think about x. Y equals x, that's just the equation of a line. So I could have a line that has a positive slope, and I could have a line that has a negative slope. So let's think about this now. What do we notice about when they are odd and they are opposite of each other? I have one that goes down to up and one that goes up to down. right? And if I were to connect them from left to right, the slope of that line is going to describe positive versus negative. So that's just a way that I can kind of remember that leading coefficient test, okay? So remember, it's going to tell me this leading coefficient test. I'm going to look at the highest exponent and the coefficient in front. The highest exponent is going to tell me what is the name, what's the degree of that polynomial. It's going to tell me how many possible solutions I might have. And if I subtract 1 from it, it's going to tell me how many possible terms or extremes that I would have. If I look at the combination of the value in front, my leading coefficient, the value in front, and the highest exponent, I can come up with what the ends would look like. Okay, so they could either both go up, both go down, or they could be opposite down to up or up to down. So all of this is kind of just memorizing what that's going to look like.